Welcome to Chapter 4, Descriptive Statistics. This chapter is really the foundation of everything we'll do in business analytics. And before we build models or make predictions, we need to understand our data, and that's exactly what descriptive statistics gives us. So let's get started. So what is statistics? And David Hand, who was a past president of the Royal Statistical Society, really described statistics as both the science of uncertainty and the technology of extracting information from data. And I love that framing because it really captures the both sides. Statistics helps us deal with messy, uncertain data, while giving us rigorous tools to pull real insights from it. And more formally, statistics involve collecting, organizing, analyzing, interpreting, and presenting data. Notice that analysis is only one step of the entire process, and collecting good data and presenting results clearly are just as important. A statistic with a lowercase s is a single summary measure like an average or a percentage. And descriptive statistics specifically means methods for describing and summarizing data, using tables, visuals, and quantitative measures. Before we can summarize data, we need vocabulary for talking about it. A metric is a unit of measurement that lets us objectively quantify something. Customer satisfaction scores, delivery time, monthly revenue, stuff like that. A measurement is the act of collecting data for that metric. And a measure is the specific number you get when you take a measurement. There are two broad types of metrics. First is what we call discrete metrics. This comes from counting. The result is always a whole number. You can't have 2.7 defects or 3.4 incomplete orders. And examples include the number of customer complaints per week, the number of errors on an invoice, or whether a delivery was on time or not. Now, continuous metrics are based on a continuous scale. Any metric involving dollars, distance, time, weight, or volume. These can take any value within a range, not just whole numbers. A shipment might weigh 24.73 kilograms. A transaction might take 0.003 seconds. And that's what we mean by continuous scale. Now, within those two categories, we can be even more specific using measurement scales. There are 4, and they form a hierarchy where each level has all the properties of the one below it plus more. First is categorical or nominal data. Just categories, no order. Eye color, product type, payment method. You can count observations per category, but you can't rank them. Second is what we call ordinal data. This is like categorical, but now the categories have a meaningful order. Customer satisfaction ratings, poor, fair, good, or excellent are ordinal because we know that excellent is better than good, for example. However, the gaps between levels aren't necessarily equal. We can't really say that the gap between excellent and good is exactly the same as the gap between good and fair, for example. Third is what we call internal data, ordered with consistent differences between values, but with an arbitrary zero. So, for example, temperature in Celsius is the classic example. The difference between 20 and 30 degrees is the same as between 30 degrees and 40 degrees. But 0 degrees doesn't mean no temperature, it's just the freezing point of water. And calendar dates work the same way as well. Lastly is the ratio data, like interval but with a true zero. And here 0 means the complete absence of what you're measuring. Revenue of 0 means no revenue. Weight of 0 means nothing. And this allows ratio comparisons where $100,000 order really is twice the time of a $50,000 order. And as you can guess, most business metrics are ratio data. And what we often see is a confusion between interval data and ratio data. And really the way to test it is, does 0 mean none of it? And if yes, it's a ratio. Where again, the temperature of 0 doesn't mean no temperature, while a revenue of $0 really does mean no revenue, and that's the distinction. Let's apply this to the purchase orders dataset that we'll return to many times in this chapter for our example. So here we have supplier name, item description, and item number, which are categorical data. They're just labels with no inherent order. There's no order between Halki fasteners and alum sheeting. Order date and arrival date are intervals. Dates have a consistent scale and we can meaningfully subtract 2 dates to get elapsed time, but there's no true 0 date. Then we have item cost, quantity, cost per order, and AP terms being all ratio data because they have a true 0 and ratio comparisons make sense. Again, a $500 order really is twice as expensive as a $250 order. Lastly, order number is ordinal because the numbers imply a sequence, but the difference between order 1001 and 1002 isn't meaningful. So as you can see, getting classification right matters because it determines which statistical operations are valid. You wouldn't average a list of supplier names, but averaging cost per order is perfectly meaningful. Now let's start summarizing data. The most fundamental tool is the frequency distribution, where we have a table that shows how many observations fall into each group. When we visualize that as a column chart, we call it a histogram. These two tools, table and chart, work together throughout this chapter. For categorical data, building a frequency distribution is straightforward. We just count how many observations fall in each category. And in Excel, it's the COUNTIF function that does this in one formula. The syntax here is COUNTIF with range coming in first, followed by criteria. The range is the column of data you're searching, and the criteria is the specific category you want to count. For this example, we're going to use the purchase orders data. Notice that in column D, we have the item description, where we have descriptions of each of the items. And so here in a new column, L, I have listed the unique item names. And next to it, I have the frequency column where I'm going to use the COUNTIF function to count the instances in which these items appear in the data. So I'm going to use the COUNTIF function, and I'm going to count from our column D. So I'll select the data, and we're always going to search from this range of data from D4 to D97. So I'm going to lock the range by using $signs or by using the shortcut key F4. Then our criteria is, in this case, airframe fasteners. And we can see that airframe fasteners appear 14 times in our data. We can find the numbers for the rest of the items by copying the formula down. Once you have counts, then we can create a column chart to visualize them. You can highlight the item names and frequencies, go to Insert, and choose a cluster column chart. And this will give us an immediate visual sense of which items are ordered most and least frequently, something that's much harder to see in a raw table of numbers. Raw counts that we just saw now tell us how many. Relative frequencies tell us what proportion, and that's often more useful for comparison purposes. If 16 out of 20 orders are for item X, that's 80%. If 16 out of 2,000 orders are for item X, then that's less than 1%. And so context matters. This is the formula for relative frequency. You divide each category's count by n, which is the total number of observations. The sum of all relative frequencies must equal exactly 1. And that's your check that the math is right. And if we want to express them as percentages, then we often multiply the relative frequencies by 100. And a relative frequency distribution is pretty much a summary of the relative frequencies of all the categories. Using the purchase orders data, let's try to find the relative frequency. For this, first we need the sum of all the data points. So at the very bottom of the frequency column, I'm going to use the sum formula to sum up all the frequencies that appear, and in our case, it's 94 observations. So to find the relative frequency, I'm going to divide our original raw frequency by the number of total frequencies, which is 94. And since we will always need to divide by 94, I'm going to fix the number 94 by using the dollar signs. And this gives us the relative frequency. I'll just reduce the decimal points and then find the relative frequency for the rest of the cells by applying the same equation. Now, to see if our equation is correct for the relative frequency, we can try summing up all the numbers under relative frequency, and if it comes up to 1, then yes, our equation was correct. When numerical data takes only a small number of distinct values, the same COUNTIF approach works. Just count each specific value. So again, in our purchase orders data, when we look at AP terms, then we can actually see that it only takes 4 values, 15, 25, 30, and 45. And here, all we need to do is use COUNTIF 4 times to find the frequency, divided by n, the total, which is 94, and then we have the relative frequency distribution. And the bar chart makes it clear immediately that the 30-year term dominates. Most orders use it. And that's a visual insight that would take longer to extract from just scanning the raw data. We know that there are 4 different AP term values, 15, 25, 30, and 45. And then in the next column, we're going to use the COUNTIF function. And here we're counting the AP terms, which is under column H. And since we're always going to search from this data range, I'm going to use the dollar signs or the shortcut F4 to make sure that this range is fixed. The criteria that we're looking for is 15. And since we wanted to cycle through the list, 15, 25, 30, and 45, we're not going to fix this particular criteria value. We'll apply the same equation for all of the terms. And then to find the relative frequency, first sum up all the frequencies, which again is 94. Then for relative frequency, you divide the raw frequency by the total. Again, the total will always have to stay the same, so fix that. And we'll decrease the decimals. And then apply the equation to all the AP terms. Make sure that our calculation is correct by summing up the relative frequency and making sure that it adds up to 1. To create the bar chart, we're going to select the relative frequencies, go to Insert, Then under column chart, select cluster column. And here we've got the chart. We'll change the title. Then we'll change the horizontal axis by going to select data. And then here, let's see, under horizontal axis labels, we're going to select the terms. We can also add labels, axis titles. We can also add axis titles to the horizontal axis. And this would be months. If you want the bars to be horizontal, then go to change chart type and under column, select 2D bar and then cluster bar. And then you'll get the same chart that you see in the slides. Now, when numerical data has many unique values, listing each one manually is, of course, going to be impractical, and that's where Excel's histogram tool comes in. It lives in the Analysis tool pack under the Data tab. Click Data Analysis and then select Histogram. The dialog is going to ask for two things: the input range, which is your data column, and a bin range. Bins are the group boundaries. If you leave the bin range blank, then Excel will choose them automatically. Now, be careful here, because if you skip the bin range field, Excel is going to choose the boundaries that are often pretty awkward. They might not be round numbers, and they might not be the right number of groups. So always define the groups yourself. It takes 30 seconds, but it makes a huge difference in the quality of the output. Now that we have the relative frequency for the AP terms, we can use this information to include a chart as well. So since we have already calculated relative frequency, we can just go to Insert, select the 2D column, cluster bars, and now you have the histogram for relative frequency. Here we can make sure that our horizontal axis labels are selected correctly, because right now we have 1, 2, 3, 4, but we want that to be the AP months. So for horizontal axis label, we'll just select the month, and now it'll show you the months as the horizontal axis. Another thing you can do here is to use our Excel add-in and use data analysis. We're going to first go to Tools, Menu, select Excel add-ins, make sure that Analysis Tool Pack is selected. We'll go to Data, select Data Analysis, and under the menu, scroll if needed to find the menu for histogram. Here we need to input two things. First is the input range, and next is the bin range. For the input range, we're selecting the column H for AP terms. That's where our data is at. For the bin range, we're selecting the AP terms that we listed in our other table. And then I'm going to select labels because I have selected the headers as well. I'll have the output in the new worksheet, and then make sure chart output is selected, because only then you'll see the chart. Click OK, and you'll see that in a new sheet you have the AP terms for each category. You have the frequencies calculated, and you have the associated histogram as well. Now, when data is continuous with many distinct values like dollar amounts, then we group it into intervals first. And this requires three decisions: how many groups, how wide each group should be, and where to set the boundary. And the textbook recommends 5 to 15 groups. And that's because if you have too few, then you lose detail. If you have too many, then the groups might be mostly empty. And the width comes from a simple formula. Upper limit minus the lower limit divided by the number of groups. Set the lower limit to a round number just below your minimum value and the upper limit just above your maximum. And we can see that in action in this example. So we know that the data for cost per order ranges from a minimum of $68.75 to a maximum of $127,500. And so we're going to set the lower limit to $0 to round it down, and then the upper limit to be $130,000. And then if we have 5 groups, if we select 5 groups, then using the equation, the width of each group is going to be your upper limit minus the lower limit divided by the number of groups, which is going to be $26,000. With 10 groups, you'll be dividing by 10, which means each group will be covering 13,000. Let's try using the purchase orders data to create our histograms. So we'll try both the 5 group and 10 group histograms for cost per order. We know that the data ranges from a minimum of $68.75 to a maximum of $127,500. So we're going to set the lower limit of the first group to 0. And then using our equation, we know that for 5 groups, the width of each group is going to be 26,000. So each group will just add 26,000. And we'll do that until 130,000. And we'll just create an additional group called more. Now let's try counting the frequency. So in the case of the first group, we're counting the number of cost per orders that have $0 or less. We already know the answer, but if we were to use our Excel formula, we can use the COUNTIF function. Again, the range that we want to check is the cost per order. And we want this range to always stay the same because we're looking at the same data set for all our frequency calculations. So we'll use the dollar signs to fix that range. And then our criteria is that we need cost per order observations that are less than 0, which is in cell L4. So we're going to wrap in quotation marks the less than, and we're going to join that with our actual criteria, which is 0, that's in cell L4. Here we need the join because we're joining the cell reference along with our comparison. And as expected, it's 0. Now, with the second group, we now have 2 criteria because we're trying to count the number of cost per order observations that are greater than 0, but smaller than 26,000. And in this case, because we need to have multiple criteria, we're still going to count, but with multiple criteria. So we're using COUNTIFs. And then the rest is still the same. The range is going to be your data in the cost per order column. Again, we're going to be fixing this because we're always going to search from this same data set. Our first criteria is that the value has to be greater than 0, which is in cell L4. So again, same thing, greater than, and then you join it with the cell that you want to reference. And then you do the same. Now for the second criteria, again, you're selecting the same range, which is the values under cost per order. And then the second criteria that we have is that it needs to be less than or equal to the value in cell L5, which is 26,000. If anyone spotted my mistake, I got the operators incorrect. So again, always double check. In your range, you're looking for values that are greater than or equal to 0, and then values that are smaller than or equal to 26,000. And that gives us 68. Now we can apply that equation to the rest of the cells. And now we have the frequencies. Another way to check is to make sure that your sum of frequencies add up to what you know, which is 94 observations. Now let's create our histogram. Now if you select the data and then insert a clustered column chart, there's your histogram. Or we can take a shortcut and just have the bins ready. Then once that's ready, then you can go to data, go to data analysis, select histogram. Our input range is for cost per order, which is under column G. Our bin range is under column L. Since we have selected the headers as well, make sure labels is selected. We'll have the output in a new worksheet. And let's have the chart as well. Then by using the data analysis, we can see that the frequencies are already calculated and there's a nice histogram as well. I'll leave this chart up here, and then we'll do the same with the upper group limit and frequency. The difference is that we'll start with 0 and then we'll have smaller size bins. So instead of the bins being 26,000, it'll be 13,000, and we'll create the bins up to 130,000, and again another additional one for more. And then for frequency, we're doing the same thing as before. And here I've just copied and pasted the same equation from before. But notice that your criteria has updated to L14 because we didn't fix that, while for the range that we have fixed with the dollar signs, that one hasn't changed. Now we can also copy over the equation for the second bin, and then we can apply that to the rest of the bins. Now with the frequencies filled in, we can again create a histogram, and now we have a histogram for 10 bins as well. Now you can see in the 5-group version that this is relatively a little coarse. Everything is kind of crammed into one big spike here, and we can't really see the shape. On the other hand, when we look at the 10-group version, this reveals the distribution better. We have right skewed distribution where most orders are small with a very, very long tail of large orders. And here the lesson is more groups gives more detail, but of course there's a point of diminishing returns. But for this data, 10 groups is the right call. And this is something that you'll just develop with practice.